All right, cool. Alrighty, y'all. So try to make this quick. This was a super simple one. So basically, it's very similar to the linear regression, just it's logistic regression, which kind of makes it easier because then we don't have to worry about R squared. We're just worried about p values. So it says find out how a level of person's partisanship, party ID 7.n, influences who she votes for in the 2008 presidential election. Use the McCain vote variable created in Lab Notes 12. Then evaluate the methods we used in class, which is just checking the p-values. So from Lab Notes 12, we did this right here. The creating the McCain vote by using the if else on McCain, 1 or 0. And then so from there, we create a logistics regression using the G. Oh, there's Pauline. Hey, Pauline. Might take a second connecting audio. Hey, Pauline.
Hey, sorry I'm late.
No worries. We're just getting started. So,
Awesome.
Like I was saying, for the first question, we're using party ID 7. And the first thing we have to do is create the McCain vote variable by using the if else, which basically it takes all of the who they voted for in 08, and if it turns it like if they voted for McCain, it counts as a 1, and that's how we get this. And so then we're just doing a logistic regression of how people voted for McCain and how the party ID 7N affects that. So the McCain vote is your dependent variable, which is being changed by the party ID, your independent variable. And so when we do a summary, this is the information we get. So we see right here, we have our intercepts and then our party ID. So basically for every, 1 spot on the party ID, it changes a 1.13%, and it's significantly, statistically significant all the way up to the 0.999. And then it just talks about the degrees of freedom. And so it says for our evaluation, we have the p-value of the 2e to the negative 16th, which means the relationship is significant to 0.999. And this implies that party ID 7.n variable is an important factor in how people decide who to vote for.
Okay.
So this first part was really super basic. You just had to remember how to set up this if else, and then put that into your logistic regression. Are there any questions on this?
I do have a question.
Okay.
Just as a refresher, so the McCain vote variable, that's our Y, right?
Correct.
Okay, and then the party IDs 7s are X.
Yep.
Okay, just making sure. Thanks.
Not a problem. Any other questions?
I'm good so far.
All right, cool. So now we'll go on to question 2, which this one, what is the predicted probability of voting for McCain at the minimum value of party ID and the maximum value? So for this one, if we go back to Lab Notes 12, we get this right here about predictive probability, which is a 1 divided by 1 plus the exp of negative beta naught minus beta 1 times x, which is super confusing. But so what you have to do is you take the information from what we got from our regression. And we're basically, so this is our beta naught, our intercept coefficient. And so we're basically plugging in this and this into this equation. So it's negative beta naught, or negative intercept coefficient, minus beta 1, which is sometimes we've called it the slope, but it's the coefficient next to our independent variable. So when we put those in, we are creating predictive probability. That's our function. And it's a function of x. And so we have the 1 divided by 1 plus exp, open parentheses, and our negative beta naught, which our negative beta naught is a negative, or our beta naught is a negative number. So when we take the negative of it, it turns into a positive number. So we have a positive 3.7893 minus our beta 1. So minus this 1.13036 times x, and then a whole bunch of closed parentheses. And then he told us that our x values for our sequence, so this example in the lab notes 12 was a Hispanic term. So you have 0 to 100. So he had a sequence of 0 to 100 by units of 1. Now our party ID 7N only has 7 options. You have 0, 1, 2, 3, 4, 5, 6. And 0 is considered an option. So that's why it's 7. And so we have a sequence that starts at 0, it goes to 6, and then we do it by 0.1. And so we're looking for the McCain minimum value at, so that would be the predictive probability if x equals 0. And then we're looking for our predictive probability at the maximum value, which is 6. So when we do this, the predictive prob, and then in parentheses, we're basically like, so we want to run this function where x equals whatever we put in this parenthesis. So predictive probability of x equals 0 and predictive probability of x equals 6. So when we run those, we get for 0 is a 0.022222786, and then a predictive probability of 6 is 0.9525673. So now what this means is you have to remember 0 is like super duper duper liberal, like as far left as you can go. And so if someone is that far left, there is a 0.0222786, or basically a 2% chance that they're going to vote for McCain. Whereas someone who is on the opposite end of the spectrum is labeled as a 6, being super right-wing conservative, diehard, Republican, there is a 95.2% chance they're going to vote for McCain, just based off of what they identify, which party they identify as. Any questions on that?
No.
All right. So then this next part is where you're plotting it. And so it's just a super simple, you're just plotting x values, predict plot x values. And then I labeled my x and y just so that when it comes out with this little chart, it looks super nice and fancy. So what this does is this was a visual check to make sure that these make sense. So right here, you have your super left-wing people. And so they almost are not going to vote at McCain, because these are basically probability. It's like a percentage of 1. 1 being they vote for McCain, 0 being they won't vote for McCain. And so, you know, if someone's super far left-wing Democrat, there's a really low chance they're going to vote for McCain. Whereas if someone is super hardcore Republican, there's a very high chance they're going to vote for McCain. And so what's interesting is that when I actually ran this, mine looked opposite. And I found out that I actually had a mistake in this formula where I had this number positive. And so by double checking against that, I was like, wait, that doesn't make sense. Like, you know, more liberal someone is, the more they're going to vote for McCain. No, that's wrong. And so I went and double checked and was like, oh, yep, I made a mistake. So then when it comes down to the evaluation for this, it's just simply the predicted probability of a person voting for McCain when they identify at the minimum value on party ID 7.n variable is 0.02276. And then for the maximum is the 0.95. And that is homework 5.
Awesome.
Like I said, he kept saying this one was going to be harder. I thought this one was super easy. I was like, that's why I brought it in. Like I printed it out beforehand. And I was like, can you check this? Because I feel like it was too easy.
It's because you get this. Like, this is your language. For me, it's like a foreign language.
Code's easy.
For you.
Yeah.
I do have a question, Gavin.
All right, go ahead.
In the R code for the X values, we go from 0 to 6, but why do we go by 0.1?
I'm pretty sure that that's just so that we have more than just 6, what is it? Like measures.
Yeah.
Because otherwise, you know, this line is just going to be, you know, if you did it by at 1, you're only taking 6 measurements. Whereas doing by 0.1, you're checking it, what, 60 times?
That's right. Okay, I see. Thank
So
you.
I'm pretty sure it's just literally to get a more accurate feeling. Let's, you know, we can actually do this real quick just for, let's change this to, let me just run all this real quick. I don't know how much of this has been ran. Okay, get all that. Can we run this? And let's see what happens if we change that to 1. All right. And so honestly, it looks exactly the same on the minimum. And if we do the maximum, yeah, those are still the same. And let's see how it looks.
Yeah, mine look different on the plot.
Is the plot required for the homework or? 'Cause
I don't think so, because it didn't ask it. It's just, it was in the lab notes 12. So I just.
I really want to include it in my paper, but it's giving me an error that I'm not sure if I'm doing the code wrong or anything, but I get the same answers though, you know, like the 0.022.
Are you getting the error in plot.new parentheses figure margins too large?
No, I have a different error. It says there's an unexpected comma. I'm going to delete some commas and see what happens. But if it's not required, I'm not going to stress about it. But you've been very helpful, man. Thank you very much.
Not a problem. Okay, so yeah. Okay, there we go. I got it. So if you see here, with only doing by 1, you see how it's just like, it's very like,
Yes, Toby. Yeah. Yeah.
I don't know. I mean, you can see it's not smooth. It's not a smooth line. It's very like it, because you're only doing 6 measurements. Whereas this one has 60 measurements, so there's a whole lot of data to make it a little bit smoother.
Got it. Thank you.
So, yep, so that's the only reason why. I mean, you could do 0.01 and make it even smoother. But yeah, so that's one of those things where you just going by what your data set is. You know, if it's something like a feeling thermometer that has 100 degrees in it, you can go by one. But if it's something that only has 10 or 6 or 3, then you might want to go by a lower number.
That's right. Cool. Thank you.
Not a problem. Any other questions?
I think we're good for now. I'll text you if I have problems with the R code.
Yeah. I mean, like, all of this, like, because this is exactly my code and everything. So
Mhm.
it'll all be, you can, once I upload it to YouTube, you can always just pause the video so that you can copy it down.
Right, okay. Yeah, so I won't interrupt your special weekend.
No worries. All right. But yeah, feel free to text me and I'll get back to you as soon as I can. If any of you guys have any other questions, that way you're not left hanging for Monday.
Awesome. Thank you, Gavin. Happy Easter and happy birthday to your fiance.
Thank you so much. Y'all have a great one.
You too.
Thank you. You too. You have a good one.
Thank
Bye.
you.
Bye.
Bye.
Bye-bye.
Bye.